These problems are going to be function notation examples. So we want to just make sure we have more depth to the types of problems we do by doing more examples with functions. So when we look at these, I'm going to start with f of x equals 5x minus 3x and g of x equals 3x plus 6. I'm going to use those as my two functions. Remember, when you have an open dot between these two, that means the same thing as if we were to do just this notation, f of g of x, like this. And so that means the g function is going to go inside the f function. That's what composition means. So I go to the f function first here, and I'm going to take the x out from it, and I'm going to put the g function as the input where the x was, so make this 3x plus 6. And now when I work with those two, I get f of x equals, I'm going to do 5 times 3x is 15x plus 30 minus 35. And so I get 15x minus 5 for my final answer for the composition of functions. Okay, for this next one, it basically says, let's take this and do f of 3 first. So I'll put 3 into this f function. So where there's an x, I'm going to put a 3. And where I'm going to put the, I'm going to simplify that then. 5 times 3 is 15 minus 35. And that's going to give me a negative 20. Now I'm going to go back here and say that means I'm going to do g of negative 20. I know what f of 3 is. It's negative 20. Let's put that back into that function and figure out what g of negative 20 is. So I'm going to get 3 times negative 20 by putting it in for the x here, plus the 6. So you get negative 60 plus the 6 will give me negative 54 for this answer. So that's the answer. This was just a step to help me get there. All right, let's do g of negative 10. Notice that it's the same function. I'm going to put negative 10 into it, get the answer, and that answer becomes my input. So I'm going to do g of negative 10 first. So go to the g function, put negative 10 in for x. So you get negative 30 plus 6 equals negative 24. Now I'm going to go back and I'm going to put in negative 24 in for this. So I'll get back to my g function, take out the x, put in a parentheses, put negative 24 in for the x. Okay, now I'll go to my calculator and I'll do 3 times negative 24 plus 6, and I get for that a negative 66 for that. Okay, so that's my final answer where I took the output of g of 10 and I made that the input back into the same function to the g function. Now next I want to do the inverse of g of x. So the first step for doing the inverse is to change the g of x into y equals. So I'm going to make it y equals 3x plus 6. That's your first step. And then what we do to actually do the inverse step is where you swap the x and the y. So the x comes over here, the y goes over to the x spot, they swap places, everything else stays the same. Now I'm going to solve for y. So I'm going to subtract 6 from both sides to get at that y and divide everything by 3. And so you get x minus 6 over 3. And so my inverse is this function, and how we usually list it is with a little negative 1. We put g negative 1 of x is equal to this inverse function that we just figured out. So that's how we list the answer. All right, and lastly we want to do, on this type of problem, we want to do f minus g. So I'm going to take my f of x function. This is the same thing as just doing f of x minus g of x. And the warning on this is to make sure that we distribute through the negative on the second one. So f of x is equal to 5x minus 35. put it in parentheses just so that I make sure I distribute on the second one through the parentheses. And then g of x is 3x plus 6. All right, now let's go ahead and figure out what these two are. So let's go ahead and distribute first. So 5x minus 35 minus 3x, and then distribute it through to that and get a minus 6. Now let's combine like terms. 5x minus 3x is 2x. Negative 35 minus 6 is negative 41. So that's my answer for subtracting the two. Again, I can't emphasize enough, make sure that negative gets distributed through the second parentheses. All right, now notice that we're going to take this problem here. What we've got is, notice I've got 5x minus 35. I'm going to show that its inverse is this 1/5 x plus 7. When we ask to verify that two are inverses, not to find the inverse or ask, are they inverses? If it says verify, then our assumption is that they are inverses, and we have to prove it by showing f of g of x equals x and g of f of x equals x. So we have to do two composition of functions in order to prove this. So this is a kind of a step-by-step process to verify it. It's like an algebraic proof. So let's do f of g of x first. So remember, for f of g of x, that means take the f function, and we're going to take the x out of it, and we're going to put the second function in that spot. Okay, now when we multiply that through, I get 5 times 1/5 x is just x. 5 times 7 is 35. Minus 35 is equal to x. Now you have to show that some of this work, because if you just say this is equal to x and I did it in my head, you haven't verified it. You haven't shown that that's the case. So you want to verify it by showing that work. Now let's do g of f of x. Let's verify it by putting the one into the other. So I'm going to take the g of x, I'm going to put parentheses where there's an x, and put in that place the f of x, 5x minus 35. And now I'm going to distribute through. 1/5 times 5x is equal to x. 1/5 times negative 35 is negative 7, plus 7 out here. And those two get rid of each other, so I just get x. So it's been verified by doing the f of g of x and the g of f of x. All right, so we have some basic problems here. We want to show how to do operations on functions, how to do composition of functions, and we want to show that how we can verify things are inverses and find inverses. These are some of the basic problems that we're reviewing of the different function notation problems we've done.